Good afternoon, everyone, and welcome to the Oxford Martin School. I'm Carl Frey, and I'm Associate Professor of AI Work and Director of Future of Work program here at the Oxford Martin School. And today it's my great pleasure to introduce Maximilian Kasy. Max is a professor of economics here at Oxford. He received his PhD from Berkeley, then held positions at UCLA and Harvard, and he's been working in the intersection of machine learning and economics for a long time, long before it became fashionable, and he's been writing many influential papers on related topics. He's here with us today to talk about his new book, The Means of Prediction, a term I wish I had coined myself, which was published by Chicago University Press end of last year. Max will speak for 40 minutes or so. We will then have a conversation, and then, no less importantly, open it up for questions. I should remind you that this event is being recorded, and so if you don't want to appear on the recording, then do not ask a question. Afterwards, there will be a drinks reception and a book sale. Max, I think, will stay around a little while to sign some books, if you like. And first, though, we need some food for thought. So, the floor is yours, Max. Thanks for being with us.
Well, thank you for the kind introduction. Thanks, everyone, for coming today. So, as Carl was saying, this book just came out a couple months ago with University of Chicago Press, and I will talk about it for about half an hour now, trying to give you a kind of some of the main ideas. Now, if you've read news in the last few years, and especially if you're interested in questions of AI, chances are you will have come across some version of the following story. Right, so this is a story that many people like to tell in Hollywood, in Silicon Valley, and elsewhere. And one version of the story goes as follows. We are close to the point where AI reaches the level of general intelligence, human-level intelligence, superintelligence, various terms being thrown around. And at that point, because it gets smarter than humans, it will start to self-improve exponentially, being better AI engineers than humans themselves. And eventually, because the objectives of AI are somehow not quite the same as those of humans, there will arise a conflict of interest between them. Humans might want to turn off the AI, and to prevent that, since turning it off would prevent its achievement of its goals, AI has to kill all of humanity, and that's the end of the story. Now, this story is one that's been told many, many times. With AI, with kind of non-AI versions, magic, gods, demons, and so on before. But in particular, in the context of AI, at some point I looked it up and found around like 40 different Hollywood movies that all have the same plot. So starting with in the 60s Space Odyssey, that's the story of like the board computer hell that ends up trying to kill all the astronauts on board because they might get in the way of its secret mission. In the 80s, you got movies like Terminator, and more recently Ex Machina. The Matrix is another series with that same premise, and so on. So there's many, many versions of that. So clearly something resonates a lot about these stories. And I think one reason they resonate a lot is because they really get to our deepest fears, right? So it really gets to the heart of things. Like it's about machines or incomprehensible entities somehow threatening our livelihood, our income, our jobs, but then beyond that, our autonomy. They are controlling us in an incomprehensible way and eventually threaten our survival and the survival of all of humanity. And all of that is in the stories is happening not due to some decisions, but because of some incomprehensible, inscrutable, and inevitable forces that are just coming at us. Right, so I think there's good reasons that these stories resonate. What maybe is a little less clear is why people in the tech industry love this story so much. Right, so anytime you hear somebody like Elon Musk or Sam Altman or whatever give a congressional testimony or something of the sort, they like to bring up some version of this story. And I think there are good reasons for that, and I will talk about that. But I think those reasons are in some ways the same why these stories don't enable us to make good decisions about AI. Right? So for two broad sets of reasons. One is these stories make AI seem like it's just something that's happening to us. Right? It's just some fate that at best we can try to get ahead of the curve, but AI is coming either way. There's no, somehow it's just happening. It's incomprehensible, and in these stories, typically, starting with Space Odyssey and so on, it's always some version of this man versus machine story. So usually it's a man, right? So there's a total obscuring of the fact that there are conflicts over who controls the AI, but it's just machine versus human, as opposed to recognizing that there are different humans. Right, and so I think those two broad sets of reasons, making it seem like something that's just happening either way, and something where at best there's a conflict between humans and machines as opposed to different humans, I think precisely the reason why these are useful stories to players in the tech industry. And so the argument I'm making in this book, or the story, if you want, that I'm telling, is a different one. In this story, AI is not fate, right? And it's not fate either in the doomer version of the scenario, like this one, but also not fate in the boomer version where somehow it's coming and it's going to solve all our problems, and intelligence is the last issue we have to solve, and then cancer and climate change and everything else is solved. Instead, it's a matter of agency. There's many, many choices to be made along the way, how to develop this technology, how to use it, how to deploy it. And to make that argument, the first thing to ask is, what is AI? Right, so that's something that's often very mythologized. It's easy to project all kinds of things into AI, which is almost built into the agenda of the discipline from the start, with this idea of the Turing test, where the goal from the start was to build machines that somehow are indistinguishable from humans in some experiments. But if you look under the hood, and if you open any textbook of machine learning or AI, the answer to the question what AI is always going to be it's about building optimization algorithms. Right? So what that means is there is always some numerical objective, some measure of success. It's usually called a reward function or a loss function in machine learning. And there's some set of actions that the algorithm can choose. And the goal of the algorithm is to achieve a high reward over time or a small loss over time, depending how it's put. And it does that over a certain set of permissible actions and based on different kinds of information that it might have. That information might come in different forms. So in kind of older school versions of AI, like expert systems, that information is kind of hard-coded into some logical knowledge databases. But in pretty much all of modern AI, it is based on kind of automated statistical analysis of data of some form or the other. But either way, and throughout all these different branches of AI, it's about optimization, about some numerical objective that's being optimized. Now, in these stories, right, so one kind of the more academic version of these stories of the man versus machine conflict, we can translate them into a more academic articulation of the problem, which is that there is some optimization failure. And that's what the vast majority of discourse in computer science around problems of AI and social impact and so on is something went wrong with the optimization. Maybe we slightly mismeasured the objective, maybe there's something wrong with the data, maybe something went wrong with the optimization algorithm and so on. And that's kind of natural, right? If, the training of engineers and computer scientists in particular is 2/3 training to come up with procedures for optimization, right? And they're extremely good at that, and kind of as a consequence, the first place to go to when you're diagnosing problems is figuring out what went wrong with the optimization. There has to be an optimization failure, let's try to fix it. But I think the much bigger question with AI and machine learning is not, are there optimization errors? Those might happen sometimes, but I think they are a second order issue relative to the first order question, what it is that we are optimizing here. What is the numerical objective that we're putting in the system? What's being maximized here? And kind of closely related, the question, who controls what's being optimized? Who makes the choice what these numerical objectives are? Right, and so in order to see that, of course, you have to go beyond the world where there's just the objective is given to you and then you try to figure out how to best optimize it. You ask, like, different people have different goals. There's inequality, there's conflicts of interest, there are different values. People have different knowledge and information. And for all these reasons that economists spend a lot of time thinking about, there will be conflicts of interest over what AI should optimize. Now, we can talk normatively about that, and I do that in the book to some extent, like what AI should be optimizing. But there's the counterpart of who gets to actually decide what AI optimizes. And in the world that we live in, who gets to decide what AI optimizes is largely the people who control the inputs into AI. That's where the title of the book comes from, the means of prediction. Right? So those are the key ingredients that you need in order to build AI systems. And there's different combinations of those for different application domains, different particular implementations. But by and large, the two most important means of prediction are data and compute, right? So I mentioned that modern AI is mostly based on machine learning, meaning automated data analysis. And in order to do that, you need computers, and both of that at an incredibly massive scale at this point, right? So something that's maybe not always appreciated is like the key ideas of machine learning and modern AI. They've been pretty much around for a long time. There's, of course, all kinds of like engineering tweaks and so on, and all kinds of smart things that people have come up with. But the basic ideas have been there. What's really changed is the scale of these inputs. And that's how we saw like some 15 to 20 years ago now, like the first big successes of deep learning were in image recognition, right? So for a given picture, recognizing is this a dog or a cat or who's in that image and so on. A bit later, we saw their successes in gameplay, and later then, and more recently over the last 5 years or so in language modeling. But all of those were essentially consequences of scaling up the inputs of data and compute. And then also important, but a bit more second order, is the relevance of expertise. Right? So at this point, AI engineers still make a lot of money, although a lot of that is spreading around more. But a lot of the big AI companies are very secretive at this point about the exact details of what they're doing. So they try to keep some of that information closed for as long as they can. And increasingly, energy is an important input. So all the major AI companies are investing in nuclear power startups now to run their data centers and so on. But okay, so we have this argument AI is optimization. We might have normative ideas what should be optimized. There is facts in the real world about who is controlling what's being optimized. The question is, if those two are different, how can we close the gap? And so the ultimate argument in the book then is to say that we need democratic control by the people who are being affected by AI systems about what the objectives of these systems should be. I'll talk a little bit more later about what exactly I mean by that. But before I do that, probably when you think of AI these days, most people first and foremost think about language modeling, chatbots, ChatGPT, Claude, and so on. And those are incredibly interesting, and there's a lot going on there. But I think there's many other applications that are at this point more mundane, but very much embedded in our society and economy and states in ways that are incredibly consequential. And so the examples I want you to keep in mind throughout when I talk about AI here is not just language modeling, but things like algorithmic management of gig workers, right? Think of platforms like Uber or Lyft, for instance, where an algorithm decides who gets what wage, who gets to work, when do they get to work, under what conditions. Think of applying to any large firm for a job these days. What they're going to do is take your CV and recommendation letters and whatever you send there. There's going to be an AI system that filters your application to decide who even gets invited for a job interview. Or if you go online, any search engine, any social media platform, there's going to be an algorithm that's going to filter all the information that you're going to see, right? So our entire sense of the world is in a way like filtered by AI systems at this point. A large chunk of which, of course, is still dominated by the goal of ad targeting, which is still by far the largest revenue source for the tech industry, is maximizing the number of times you get to see and click on different ads, which is how Google and Facebook and other major companies made their billions. But beyond these commercial applications, there's also, of course, various state actors that use AI in controversial ways, right? So in predictive policing and incarceration, maybe most notably at this moment, ICE, Immigration and Customs Enforcement in the US, uses a system built by Palantir called Immigration OS that's combining a lot of public data sources, which decides basically to target the raids and who gets to be put in camps now. with the objective function being to put 1 million people in deportation camps. And one more consequential in the recent bombardment of Gaza, it was algorithms that decided who got to be bombed and when. Systems called Lavender and Very Steady predicting who's a target and when they would be at home so that the home could be bombed. But so obviously in all these cases, it's very consequential if you're at the receiving end of these algorithms, whether it's about getting a job, whether it's about what kind of news you see about the world, or whether it's you get incarcerated or bombed. And there's arguably space for disagreement over what the objectives of these systems should be. And the people at the receiving end might often have different opinions about what they should be relative to what they are. All right. So with that being said, what the book does is it has 3 major parts. The first part is trying to give a non-mathematical introduction to how AI works. So that's what I teach here. I just come from my master course in the economics department on the foundations of machine learning, and a lot of what this part of the book does is kind of a non-mathematical translation of these key ideas of AI. Now, of course, this is constantly evolving, and I mean, at this point, I finished writing the book a year and a half ago. Things keep changing, but a lot of the key underlying principles don't actually change that fast. And as I was saying, many of the key ideas have been around 50 or 100 years ago in statistics in some form or other. And so the key trade-offs kind of stay the same, it's just that they play out at a larger and larger scale. And so I think that I'm reasonably confident that most of these points will still be relevant 20 years down the road because there are kind of some fundamental trade-offs that underlie these systems. And so the first thing here to note again is to drive home that point, what is AI? The textbook definition in any computer science textbook is it's about automated decision making. Right? Decision making here meaning, again, you have a numerical reward or loss function that you're optimizing. You're doing that over some space of actions. Right? So that might be over which workers get invited to job interviews or which ads get shown to whom or who gets targeted for a deportation rate. They do that based on some information, whatever data sources, say Facebook collected about you online or whatever data sources Palantir got from the US government and so on. And at the end of the day, they have some numerical reward that somebody literally had to put in the computer. How do these algorithms do that? Again, at this point, it's mostly machine learning. Historically, other systems or other approaches dominated AI, and machine learning was kind of more a fringe subfield of AI. So in the 80s, it's often forgotten, we had a big AI boom and crash around so-called expert systems, right, which were basically built on like, taking human expert knowledge, putting that in some form of database and having automated reasoning based on that. That approach didn't go that far in the end, and what distinguishes the machine learning-based approach is just that it's scalable without direct human labor by just say taking all the data on the internet and running them through massive server farms and data centers. Now, within machine learning, there's different sub-branches, and so now it gets a bit more specific, but I think it's worth talking a little bit about that. One branch of machine learning is what's called supervised learning. So that's basically about prediction. And prediction is a very powerful paradigm to capture all kinds of problems. That can be predicting from an image whose person's face is in that image. That can be predicting for a given, say, situation on the Go board, what's the likelihood of winning the game, which was the key ingredient for building game playing systems. That can be predicting what's the next word in the internet, given a set of words before it, which is the key step for language modeling. And anytime you build a prediction algorithm like that, there is key choice variables in all different kinds of algorithms around how complex or how flexible the prediction algorithm is. In deep learning or artificial neural networks, that's often reflected in the number of parameters, the size of the neural network. And that trade-off is important because it governs that is important because it governs a key trade-off here, where what happens is the more complex you make your model, the more flexible, the better you will be at reproducing any patterns in your data, right? So If you're flexible enough, you can arbitrarily kind of reproduce any patterns in whatever data set you have. And so that's what's reflected in this black curve here, where your in-sample prediction performance, as it's called here, is getting better and better the more flexible you are. But that's not necessarily going to imply that you're going to be very good at predicting patterns out of the sample. And the reason is, at some point, you just end up fitting random patterns in the data, right? So it might be that in your image data set, just every image that has a green pixel in row 23 and column 12 happens to be a dog. But then if you get a new image, chances are that pattern is not going to hold. And so that's what's called overfitting. It's basically just picking up on random patterns in your training data rather than things that will keep being there if you see new data points. And so that's why you see this gap between in-sample and out-of-sample predictive performance. Why am I telling you about this? A key reason why this is interesting from the perspective of this book is it tells you a lot about the production function of AI, basically how successful AI will be given the amount of data you have and the amount of compute you have. And in language modeling, for instance, there were, at this point, 5 or 6 years ago, researchers at OpenAI and then at Google DeepMind looked at this relationship, quantified it for language, and basically realized that given the amount of training data they had from just taking everything on the internet, they could scale up the model complexity, basically buying more and more computers, and they would get better and better at language prediction. And that's exactly what happened. Right, so you see this here. On the horizontal axis, you see the release date of different language models. And on the vertical axis, you see how many training data they used and how large the models were in terms of numbers of parameters. But what you should note here is this is a so-called logarithmic scale, meaning you go here from 10 billion parameters to 100 billion, observations to 100 billion to 1,000 billion. Right, so this looks kind of like a linear increase, but that's really an exponential increase. The training data have exploded for a while, where they threw in everything they could, right? Take everything on Wikipedia or an archive, which is a website of scientific papers, or on Stack Overflow, which is a website where programmers would talk to each other. Just feed everything in there, make the training data bigger and bigger, and at the same time, they also made their models more and more complex. But what's been happening now around 2 years ago is they basically exhausted all the possible language training data they could have. And so we very much see that in this picture, right? So we kind of started out somewhere on the left here, given the amount of training data they had, increased. But now we kind of have gotten beyond the point where increasing the model complexity is not necessarily going to pay off anymore. And so this is just kind of one example of one domain where you see how, like, thinking about how the machine learning works here tells you a lot about how these inputs matter, in this case the training data and the compute, which tells you who's going to profit from this because they control the training data or the compute, or they basically steal it, right, by, for instance, taking all the intellectual work of others from the internet. And by that, then they end up controlling what the objectives are that can be optimized here. Right, so many of these kind of consequential applications, the training data are smaller than for language modeling, but they are controlled by particular actors through various forms of surveillance or data collection, which then gives them the power to choose objectives by, again, controlling this relevant input. But just briefly, I want to say that supervised learning or prediction is not the only branch of machine learning that matters. Another very important one is what's called active learning or online learning, where the key difference to basic supervised learning is that the algorithm chooses actions and then observes the consequences of these actions. Right, so at that point, we're not anymore just in the world of matching patterns. We're at the world of basically experimenting and learning causal effects of these actions. And that's reflected in branches like what's called multi-armed bandits and reinforcement learning and so on. And again, anytime, say, you use a search engine online, they are basically doing this. They're running experiments on you to see what ads you're going to click on or not, or what is going to keep you engaged in your social media feed and whatever. And they constantly estimate these causal effects of what they're doing in order to then better be able to show you the things that maximize their profits. Yeah, and so that in that world, just to briefly mention that there's kind of this maybe second most important trade-off in machine learning, in addition to the overfitting, underfitting trade-off, is the exploration-exploitation trade-off, which is basically that any such algorithm needs on the one hand to experiment, try new things to reduce uncertainty, but at the same time use what it's learned in order to get higher profits, say in the ad placement example now. And so any system that takes actions in the world is facing this key trade-off, which determines the production function of AI there. All right, so this is just a very, very brief sketch of what machine learning is about. Why does it matter? It matters again because it tells us a lot about who is going to profit from controlling the systems by controlling these inputs. And it's going to tell us who gets to control the objectives by controlling the inputs. And furthermore, it tells us about different domains, what the potential for success of this type of approach is. Right, so I already mentioned we had kind of successively further domains could be kind of cracked with this machine learning approach, image recognition, gameplay, language modeling. Other domains still less successful, and I think there's good reasons to think there's many also where it will never be, at least in the raw form of pattern matching, simply because the relationship between potentially available data and complexity of the prediction problem is such that you're never going to have enough data. Right, so say if you want to predict the next financial crisis, there's only one financial crisis of 2008. Basically, you have one observation. There's only so much you can do by pattern matching there. This is not going to get you there in all likelihood. Or another intriguing example is genetics, right, where in the early 2000s there was a lot of hype after the Human Genome Project that we will be able to have like individualized medicine, predict diseases at the individual level and so on. Most of that hasn't panned out, and I think there's good reason for exactly the same reasons here, where the complexity of what you're trying to do here in terms of like how many genes there are and how they can interact is just at the magnitude that even if you say sequence the genome of all of humanity, you're just not going to have enough data to figure out these patterns. And last point here, and maybe also we can get back to that in the discussion after, is because data is probably the most important input here, that means that training data, and especially training data that concern individuals, are extremely prized, right? And that means that we have to think about what's the role of privacy and for like building these AI systems and controlling the objectives. But a key point here is that that any pattern learning involves what economists call externalities. Basically, it's never your own individual data point that matters, it's the pattern across people. It's kind of similar to climate change, where like it's not your own carbon emissions that matter for your risk of facing climate catastrophes. It's all our collective carbon emissions. So data collection is exactly the same, and so unfortunately individual privacy rights will not get us there to prevent any like harmful uses of AI. Now I talked about the book arguing that democratic control of AI objectives would be the answer, where those being impacted by these AI systems should have a say over what they're optimizing. Question is, how do we get there? And so in political theory, that would be called who can be agents of change, meaning which individuals or groups in society have a combination of the material interests, the values, and the strategic leverage to actually move things in a direction that we might consider socially beneficial. And now, a lot of discourse around the ethics and regulation of AI is essentially about telling engineers to be nice, right? And obviously nothing wrong with engineers being nice. I mean, what happens is like you get ethics courses in CS curricula and so on. But I think ultimately that's a pretty limited approach to the extent that if they then work, say, in tech companies, those companies are profit maximizing, making their money by selling ads and so on. That will be the ultimate goal, and maybe you have some wiggle room at the margin. But at the end of the day, the profit objective, or say the objective to sell as many ads as possible, is going to dominate. And so part of what I'm arguing for in the book then is that we should address a much wider set of potential agents of change who all have like different sets of interests and values and leverage over what's happening with AI, and who can kind of contribute to sharing power over these systems more broadly, including a lot of like levers of traditional regulatory state and the law, anything from competition law, anti-discrimination law, privacy law, all the way to technical standards like so-called interoperability rules and so on, there are many, many different levers that we have that impact how power over these systems is distributed in society. But ultimately, I think what we need to get to is some form of democratic control. And by that I don't just mean like we make a check mark every 4 years to pick one party or the other and then they do something about AI. It's more that at the level of the systems, which can be very local, or at the level of interest groups and so on, you have a more direct representation. Now, of course, having direct democracy also has a lot of constraints, right? Like it's hard for all of us to become experts in these AI systems. And so I think there's some schemes that are very attractive here, like for instance, what's called sortition, where the idea is kind of similar to jury duty, that you randomly select some subset of people who are among the stakeholders of the system, say all the drivers for a gig platform in a city, or all the users on some social media platform and so on. And then you give this randomly selected set of people the time and resources and access to expertise to make an informed decision. And then they make some binding decisions, say, over what the objectives should be here. And there are other schemes that could be interesting. But the larger point is we should think about democracy more broadly, not just at the level of the nation state and at the level of representative party elections, but instead think about other schemes that are at various levels of society and the economy. All right, so I guess I'm running short on time already. So just briefly, I mean, this is not going to be an easy task, right? So a lot of obstacles on the way to this ideal of collective self-governance in a democratic form. One of them is ideology. Now, ideology is kind of a tricky word. Right? We often use ideology to just describe the opinions of people we disagree with. But there is a more specific and useful way we can use the term, I think, the way, again, political theorists might talk about it, which is that ideology does one of several things often. One is it takes the interest of some group in society and represents them as the interest of society at large. Second, it takes it takes decisions that are contingent, that could be made otherwise, and represents them as objective necessity. So like this famous quote of "there is no alternative" by Thatcher. Or it takes things that are social relationships and represents them as somehow technical or objective. And if you take the lens of these three elements of ideology and apply them to AI discourse, I think it applies fairly well. So if you go back, for instance, to the story I started out with of this man versus machine conflict, right? There's one person that represents humanity, completely obscuring the fact that humanity consists of many different people with different interests and values. Similarly, the story of the intelligence explosion, right? It's like this is just something that's happening to us, like this almost godlike entity is coming, as opposed to there's a myriad of choices made by humans along the way on how to build these things, how to deploy them, and so on, what objectives to put into them. There is often this argument that this is all very complicated, it's highly technical, only experts can understand AI, therefore leave it to the experts in industry to self-regulate, which of course implies that it takes away democratic power to regulate these industries. And I think it's simply wrong, and that's part of what this book is trying to achieve, is to argue, sure, there's a lot of like technical jargon, a lot of things happening all the time, but the basic and relevant ideas under the hood are actually broadly accessible, and we all can discuss about should we, say, structure our democratic public sphere on social media by ad-click maximization or by some other objective. And lastly, there's often this geopolitical arguments. In the US, it's usually if we don't do it, China will, therefore we can't regulate. In Europe, it's often we can't regulate because we have to catch up to the US, which I think is also quite false. And it's, in a way, like I think AI regulation is a lot easier than things like dealing with climate change or corporate taxation, where you really can do things at the local or national level. All right. So yeah, I won't go through this in any further detail, but the third and largest part of the book then takes these frameworks of thinking about what AI is and how we can think about the political economy of AI, and then applies it to a variety of different debates that have been taking place in policy debates and in different academic disciplines, including computer science, law, economics, and others around what the impact of AI is, around questions of value alignment, data privacy and data ownership, workplace automation and the labor market impact of AI, questions of fairness and algorithmic discrimination, and questions of what it means to explain algorithms and algorithmic decisions. So maybe we'll have a little bit of time in the discussion to talk about those. But I should probably stop now. I guess there's books outside to buy, but if you change your mind later, you can also buy it online.
Max, that was certainly tour de force and a lot to ponder. So maybe let's pick up where you left us with regulation. So a narrative we often hear is that it's too early to regulate AI because we don't know where the technology is going, and it's going to stand in the way of progress and innovation. So what are your thoughts on that? Where do we stand?
I think those two can be very orthogonal issues, right? Developing the technology further, which, depending on the context, we might or might not want to do, but that's separate from deciding what we want to use it for, what objectives to put into it, right? I mean, developing the technology means, in this case, for the most part, building bigger data centers, collecting more data, training bigger models, which we might or might not want to do. But separate from that is, do we want to use it to make the, say, owners of the big tech companies richer? Do we want to use it to put 1 million people in deportation camps? Do we want to use it to other goals? And those are things we can have a debate about and can make democratic decisions about without stopping the progress of technology, I think.
So you had several buckets on the slide, including privacy, ownership, fairness. Do you want to talk a little bit about those and what you think
Sure.
What should be done?
So I think, I mean, compute is maybe the one where the input or mean of prediction, where the biggest money is at the moment still, right? Like NVIDIA, the company that produces the chips, is the one that has made the biggest profits from the AI hype, and kind of secondarily all the cloud service operator that built these big data centers. But I think in the longer run, probably the key input for control of AI is the data, and it's especially true for this less data hungry but socially very consequential applications. And so there we really have to think about control of the data. And that has several aspects. One is kind of who gets the benefits, the profits from this data, right? Whereas there's been kind of this massive enclosure or land grab basically that's been going on, where like all the intellectual labor of many, many people, whether contributors to Wikipedia or coders in Stack Overflow or musicians or artists or journalists and so on, has been kind of absorbed by these AI companies and effectively now is resold to us. So that's a massive redistribution. But then maybe even more consequentially, again, is like this individual level data. And I already briefly alluded to this question of privacy, right? Which is usually the answer that's being given to say, like, that's how we control like problematic uses of data for AI. And I think that just really misses the point of what's going on. Again, because of this externality issue, right? Where if the system wants to learn about something about me, right? I don't know, whether it's how much I'm going to pay for something or who I'm going to vote for or whatever it is, then the system can look at people similarly to me, say you share your data, maybe it has no consequences for you, but then it has consequences for me and vice versa, right? So that's the issue of externalities. And we know from machine learning theory that that's kind of at the core of these things. It's all about the externalities. And so if you have like individual privacy legislation, like for instance the GDPR in the European Union and similarly in the UK and elsewhere, that gives you individual control over your individual data, but it does nothing at the end of the day about these externalities. And so the only way I think we can move forward to prevent harmful uses of individual data will be through more collective forms of data governance, through, say, structures like, for instance, data trusts, this idea that maybe we all contribute our data collectively within some context to a third party that governs them in our interest, that we then have democratic control over what the data might or might not be used for. Right? So just to give one example, like healthcare data, right? Like predicting who is going to have certain diseases. You might use that to exclude people from health insurance, which we might think of as a harmful use. You might use it to give people early preventive treatments, which could be a good use. Both of that needs the same kind of data, but we're not going to get one use versus the other by individual privacy rights. We have to collectively govern these data.
And as you mentioned in the book, AI is, the AI community is a fairly broad church, or even an anarchy of methods, you might call it, right? So it ranges from everything from expert systems to deep learning. And so when we think about all this variety of approaches, do we also need to think about different ways of regulating each one of them? Or do you think that we can arrive at a sort of more unified approach to regulation?
So, I mean, I guess expert systems are maybe a little further afield at this point, but I mean, they share some of the same characteristics in the sense that they also have some numerical objective that's being optimized and that would need to be discussed. They have been largely sidelined within AI at this point for these reasons of scalability for the most part, I think. And so I think one thing that's distinct about the machine learning-based approach to AI is, again, the role of training data. Right? For expert systems, basically the control of the inputs comes through the expertise that's being fed into the systems. For machine learning systems, it's through the control of this training data, which might have been collected for completely different purposes often, but now are being scraped and used for training. So in that sense, it's distinct. But then within that, right, there's, as you say, like there's an endless amount of different approaches. So you could think they're all different, and it's very hard to understand all of them for democratic governance. But I think you don't need to understand this or that neural network architecture or some other machine learning method necessarily in order to understand what a given AI system is designed to do, right? Which is, again, mostly about the decision problem of what's being optimized over what set of possible actions. And it turns out what the system does at the end of the day only marginally depends on the way you actually design the system that is designed to solve this decision problem. Right, so a bit more technical, but that's what economists call identification, right? With large enough training data, it doesn't really matter which particular prediction method you use, they all end up with the same answer.
So in the spirit of democracy, let's bring in the audience. And so if you would introduce yourself briefly and preferably state your questions briefly, and preferably one of those questions with an actual question mark at the end. So we had 3 to begin with, so we have one over there.
Hi, my name is Philip Riedele from the Oxford Internet Institute, and I'm very intrigued by your idea about democratic control. But how could that actually work in practice with regulatory arbitrage between states, or should we only oversee the big frontier models? What about private small models? What about adversarial agents?
So, I mean, that gets back to this kind of geopolitical question that I was mentioning, right? This whole idea, like, oh, we can't do this like at the national or even regional level and so on, which I think misses the point that a lot of these systems you can actually think of as fairly locally. Right? Say, I don't know, a university like Oxford might have some statistical methods to predict future student test scores that might be used for student admissions, right? Then you can decide that at the level of the educational institution. Or a local police force might use an algorithm to decide where they send patrols and who's getting searched. Then you can decide that at the local level, right? So that's not necessarily about we need to take control of OpenAI and Anthropic right now, and everything else is a lost cause. We can build this kind of from the ground up in these many different application domains and areas, right? A city can regulate what the ride-sharing platform does in terms of its algorithm that's used to assign wages and jobs to its workers and so on. So I think there is a lot of scope of doing this kind of in a more piecemeal fashion and building democracy in different spheres. Doesn't mean that democracy is easy, and that doesn't mean that shifting power is easy, but I do think it's feasible.
We had another question up front here.
Hi, Fred Means, just an interested observer of AI. I was wondering why you've chosen to regulate the model design rather than the model output. So a legal requirement for it to be fair or reasonable.
So that raises, of course, the big question of what is fair, right? And that is, so the book discusses this at length, but basically I'm pretty unhappy with a lot of like the literature and discourse around fairness in CS and law for that matter. And basically if you look under the hood, like so people have thrown around hundreds of definitions of fairness. At the end of the day, they're all pretty similar, and they repeat what I think of as an unfortunate mistake of economists too, which essentially again define fairness as not making optimization errors. Right, so take the example of hiring, which is often used. Right, say an algorithm decides who gets invited for job interviews, and then the way all of these definitions, and also economists historically have defined fairness, is to say the algorithm decides to hire a man versus a woman, then that's unfair if higher profits could have been achieved by hiring the woman. Right, so those are the types of fairness definitions that people talk about when they talk about model fairness. But what that means is it's kind of an amazing ideological sleight of hand, I think, where you start out by being concerned about the interests of some presumably disadvantaged group. Within 30 seconds, you have arrived at actually only asking about the interests of whoever is in control of the system, right? And that's what a lot of the fairness discourse does. So I think instead of doing that, we need to ask what's the consequence of building and implementing these systems on those who are being impacted. How does it impact, for instance, gender inequality, inequality within genders, and so on, which is a very different question from asking this optimization error question. Is the algorithm unfair in the sense that higher profits could have been achieved by hiring a woman instead of a man?
Do we have one over there?
Rafael Ramirez from the Oxford Foresight Center. Is there an AI bubble?
Is there an AI bubble? I mean, if many would like to know, right? I think, let me give a semi-cautious answer to the question. I think there is decreasing returns to scale to doing certain things, in particular for language modeling, and I think that's being recognized by the smarter people in industry. We've reached the limit of a certain scaling approach for language modeling, where pretty clearly over the last year or two, the foundation models have not gotten better despite throwing a lot more compute at them. I think for the very reasons that I've briefly sketched, where given the amount of training data that's available, we cannot just scale the compute further and hope for improvements in predictive power. So that's led to a lot of shift, I think, in what's going on in that particular domain. Some of which is kind of coming up with more hand-curated training data for various problem domains, coding, math, legal problems, and so on, which produces a lot of successful systems, but is also a lot more expensive than just scraping the entire internet. The other thing is just to try and get more and more deployment of the existing systems. If I were to guess, I think the current investments of compute cannot all pay off. Right? I mean, just last year, $400 billion being spent on data centers. This year, another $400 billion being slated. I mean, those are massive, massive magnitudes. The way how you can kind of recoup this kind of investment, you need massive revenue sources, and clearly they're scraping, including in various rather questionable ways. Right? So, I mean, OpenAI has generated headlines in recent weeks, first by saying that it will include ad placement in its responsives. Now by striking a deal with the Department of Defense, or War now, I guess, in the US, allowing things like automated surveillance including of Americans, and fully autonomous weapon systems using these. It's basically because they're scraping for money to recoup these investments. I'm doubtful whether they're going to get there. Does it mean it's a bubble? I don't know, but
Do we have any questions online?
Yeah, question online from Philip Wilcox. We now hear outline information about US military use of AI. This appears to fall outside the realm of democratic control due to the levels of secrecy that usually apply in that field. What are your thoughts on that?
I mean, I think it should fall under democratic control. How to get there is, of course, another question, right? And moreover, I mean, it's, not that I have a good answer, right? But if you're people who are at the receiving end of the systems should have a say about what the systems do. That's, of course, very much not the world we live in. I think in an ideal world it would be that we don't build fully autonomous weapon systems that decides who gets to live and die. Yeah, how we get there, who knows? But
Would we have fewer wars if we had more democratic control over AI to begin with?
well, I mean, this question: democratic control by whom, right? Does it include the people who are being bombed? Yeah.
Any further questions online?
No, that's all for now.
So one over there in the corner.
Hi, my name's Isaac. I work in theoretical computer science for the AI governance initiative at the Martin School. This will be basically from the perspective of somebody who shares all of the values in your talk and basically agrees with the general point. The issue that I want to ask about is that trying to introduce democracy into the economy is a very difficult thing to do from a technical perspective, in the sense that just subjecting particular decisions to a democratic process is not automatically going to do what you want it to do. Classic example would be saying that we're now going to democratically control a firm, and so people are going to be able to tell the firm to do something other than try to make money. This may not end up the way you think. And so I'm wondering if you need, what kinds of economic theory you might need to reason about how the different loci of democratic decision-making would fit together in the economy as a whole.
So let me give you two partial answers to that. One is, I mean, say telling firms what to maximize, right? I mean, that is something that happens very much in many places in the world in different degrees and in different amounts over time. Say in the German-speaking or Scandinavian countries, there's a lot more co-determination where worker representative unions have a say over management decisions to some extent and with different degrees of actual power. But there are many historical examples also where worker representatives were involved in technological decisions at the firm level. And it seems very likely that impacts, for instance, whether technology is built that's automating them away or making the work easier in some ways or more interesting. So there are plenty of models of worker co-determination or maybe even decentralized worker management of firms in various forms. I mean, there's many models where this has been done with different degrees of success. But and another kind of more high-level point, which I think is interesting, but maybe a little bit more in the longer run, is, or no, it's a bit more abstract, is in the mid-20th century, there's been a lot of debate around economic planning, and not just from the left, right? A lot of conservative governments around the world, whether in France or Korea or elsewhere, had pretty strong forms of economic planning. And kind of the argument from Hayek and others has been, doesn't work because information is dispersed in the economy, and the only way to aggregate that information successfully is through the price mechanism, which has been one of the main counter-arguments against centralized planning. Now, if you look at what's happening in the modern economy, we're quickly moving away from a world where that logic applies. If you look at how, say, a company like Amazon or Uber or Google and so on operates, it's collecting information, aggregating them, and making centralized decisions, not necessarily in the common interest, but in a way where we're in some sense getting closer to some form of central planning in many domains, like predictive shipping of goods to Amazon warehouses and so on, where I think actually it makes sense to revisit a lot of these debates around how decision-making and information aggregation works in the economy that goes outside this ideal of the competitive market using prices to aggregate information.
One question over there and one over there in the middle. I can take two in one go. Over there, and then...
Hugh Fixon, just an Oxford resident. Could you tell, what would AI's prediction of the cost-benefit analysis of all the data that AI is getting, and is there a risk of data hoarding that will never be used but it's just being collected for the sake of it?
I mean, it certainly is, and I think there's, I mean, that's something where I actually kind of changed my own opinions over time, where I think there's often also a situation where data is collected for one purpose or fairly innocent purposes, and then gets used for very different and much more questionable uses, including data collection by the state and by corporations. As I already mentioned, the deportation apparatus of ICE now, which builds on all kinds of data that's just used for regular like data collection, administration of the welfare state and so on, and then becomes part of a massive deportation machinery. Or if you're kind of up at one relative to that, if you look historically at, say, what the Nazis did, right? There was all kinds of data from censuses and so on that they took that then ended being part of the machinery for the Holocaust. So I think there is real dangers of data being collected and sitting there and then changing hands in some way or other and being used, maybe being sold, maybe control shifting, being used for very dangerous purposes. Maybe a little less extreme is like all kinds of ways that maximum profits can be extracted from people by predicting how much they're willing to pay for everything, wages being depressed by predicting how likely somebody is to move jobs if you reduce the wage and so on. But there's of course also the opposite risk that data might not be collected for useful purposes because the dangerous purposes dominate. I mentioned the healthcare data example, right? We probably want to prevent the collection of healthcare data to then exclude people from healthcare based on the predicted future health risks. But we might want to collect that same data in order to improve medicine by intervening early in diseases, right? And so we want to put in place structures where we can prevent the harmful uses while allowing for the beneficial uses of AI and machine learning.
Short final question and short answer, please.
So I have one comment and then one question. So if you've used DeepSeek, I use it in the scientific domain. What I really enjoy is its reasoning where it goes down paths that don't work until it gets to an answer which it thinks is correct, and I find that absolutely golden. And now my question is, if you look at countries where they use AI and deep learning for modeling behavior, I wonder if you'd like to comment on that.
So sorry, I didn't get the question.
So there are countries that use machine learning and AI models for predicting behavior modeling of people.
Yep.
So I wonder if you could say a few words about that, because that's behavior modification on a global scale.
I mean, I would think most countries in the world do that at this point, both like private and state actors, right? And yes, that goes anything from like inducing you to buy certain things or to vote in certain ways. But then, I know you might have in mind things like, say, the social scoring algorithms in China that are used to assign rewards or exclude people from rewards based on how pleasant their behavior is to the regime. So absolutely, I mean, that's at the core of all these kind of individual level uses of AI is individual behavior prediction, individual behavior modification. That's kind of what this whole exploitation discussion that was briefly mentioning is about, is like intervening, seeing the consequences to observe people, to modify people's behavior.
So on that cheerful note, do join me and giving Max a round of applause. And most importantly, do join us for the drink reception, which is taking place just outside. And even more importantly, do buy the book because it's really a great read.